Hi, Multifarious Fisherman here. Today I'd like to talk to you a little bit about the St. Croix rod lineup. St. Croix is a US-based premium rod manufacturer. They build their rods in Park Falls, Wisconsin. I was lucky enough to go through there and take a look at their factory. They build most of their high-end rods in, well, some would argue all of St. Croix rods are high-end, but they definitely have some more moderately priced rods and some fairly expensive rods. But they're tools. They're high-quality tools. Anyway, they build most of their premium stuff in Park Falls, Wisconsin, and they also have a factory in Mexico that is not a rod manufacturer in Mexico who makes rods for a lot of different people. A lot of times when companies go overseas to build things, they go to an established manufacturer and just have them make stuff for them, and it ends up being cheaper. They throw their name on it and sell it. St. Croix's facility in Mexico is built by St. Croix. All of the techniques and systems are put in place by St. Croix. It's overseen by them, and they utilize the same technologies in Mexico, but it reduces the price of manufacturing and allows them to have some lower priced rods. I certainly wouldn't call them cheap rods or even probably inexpensive rods, but allows them to be in the 100-ish price range, as well as higher end rods that go well up into the $400 or $500 range. And I reviewed a fly rod that I bought from them. That was a very high quality piece, built in the US. Not an inexpensive rod by any means, although certainly not among the highest end fly rods. You can spend a ton of money on a fly rod if you want to. Performance of this rod in a 500-ish range is really good. They're incorporating a lot of their technology that they use to build standard rods into their fly rods. I did a video on that rod, should be available up in here. So let's talk about Alphabet Soup. St. Croix have some glass, I think SC1 glass. They have SC 1, 2, 3, 4, and 5 graphite. So the SC2, I think the Premier introduced SC2, and it is a very versatile, at the time, a really, a very high modulus graphite. They're going to call it a mid-modulus now based on the ranges that companies utilize. But a mid-modulus rod with really good all-around performance. What that permits, I fish a Premier a lot. One of the rods that you see in a lot of my videos is St. Croix Premier Rod 6.6 medium spinning. And I caught a lot of fish on that rod. It combines strength and sensitivity. People think, well, if I'm going to spend $400 or $500 on a rod, boy, that, should be indestructible. It's kind of the opposite. It's not 100%, but as you add higher end, more extreme, lighter, and more sensitive materials, you tend to get a little bit brittle in those materials. And one of the reasons that they cost more is not necessarily because the carbon scrim is so much more expensive, but it's because the way that you have to build the rod to utilize that more brittle graphite to gain the benefits in weight and sensitivity, you have to build that rod in a different way than you build a standard rod to make it durable enough to be fishable. The SC2 graphite in the Premier series and in a number of their other series is a good balance out of the gate for sensitivity and durability. It's not going to be the most sensitive rod you own. It's certainly not going to be the lightest rod you own. Although, compared to the industry, it's going to be plenty light and plenty sensitive. You get to a point in these carbons that you're not able to actually manufacture a rod from it in its entirety. Because to counteract the brittleness of that graphite, you have to add so much material to it that it ends up being heavier and you gain nothing from it. However, you can, and St. Croix does, build rods that are SC4, SC3 in segments and add an SC5 to that rod in areas where it makes a big benefit, adding a lot of strength and durability without adding much weight. When you see that SC St. Croix number, the number is indicating to you how high a modulus the graphite is in that rod. What you get from the rest of the Alphabet Soup, I say jokingly, IPC is integrated poly curve. Rods are built on a metal rod called a mandrel. They take sheets of graphite and they adhere them to a metal mandrel and they roll that graphite sheeting over that metal mandrel. The mandrel is tapered from one end to the other, but it's not tapered in a single taper. You can do it that way, but rod designers have found that by making one taper in the butt section of the rod and then having a steeper, a different taper through the middle of the rod and then having a fine taper at the end of the rod, they can adjust the action of that rod. They can adjust where that bend occurs and where the power in that rod is. They can adjust the amount of material they're putting over the mandrel, the diameter of that mandrel, and ultimately the behavior of that individual rod. So the IPC, what they found, St. Croix broke a lot of rods, and they broke their rods, they broke other people's rods. They take all of their return rods and examine them for breaks, and if they were seeing consistent break locations, they started digging into why. Why is that happening? Why are we breaking in that location all the time? And what they found was in areas where the taper changed on the mandrel, you got a little peak, a little corner. And as you wound that material around and then put pressure and heat on it, which is what makes that material into a fishing rod, they found that there was a pinch point at the bend in the mandrel where that mandrel changed taper. You would get a pinch point, and that created a weakness in the rod. So they eliminated those points by making that mandrel change its taper in a gradual curve, so that mandrel, if you look at it, has no obvious changes in taper. It's still changing taper, but it's not visible to the eye. You could feel it if you run your hand over it, but there's no peak, there's no pinch point to create a weak spot in that rod. When they lay their material around there, the graphite is a lot of little fibers, and they're kind of put together into sheeting, and that sheeting is called scrim. They get pre-impregnated, or they call it pre-preg, an adhesive material, which is the resin that holds that carbon together, makes your rod hard and not just a bunch of wound sheets of carbon material. When it bakes, it melts that pre-impregnated resin material, which infiltrates all of that carbon, fills all the air spaces, and creates a solid piece of material which deflects when you bend it. So IPC is that modification to the mandrel. St. Croix invented that, and I think they're the only ones that use it. And it reduced their failure rate pretty substantially, and that was developed quite a long time ago with SC2, I think the Premier Series when it was introduced. Certainly the Premier Series now has IPC in it. So more of the alphabet soup. ART is the practice of laying some of that carbon material at a 90-degree angle to the longitudinal fibers of that rod, so that your scrim, instead of being all unidirectional, crosses itself and creates, especially in the butt section, they can add quite a bit of stiffness and strength to a rod without adding a lot of weight. So they're using typically a higher modulus graphite and putting that in a position in the rod where it does the most good in terms of strengthening that rod without creating a lot of weight. The cross section of a rod around that mandrel rod blank is a circle. Typically, when a rod is loaded to a certain point, it will begin to ovalize. And once that rod starts to ovalize, that's usually when it's very close to failure. As you deflect that, or certainly if you're fighting a fish and you let that rod come down and make contact with the side of the boat, or anything, even if you're reaching up and grabbing that rod blank part way up, you're putting a stress point on that rod where it's going to want to ovalize at that location. And normally, if you're pulling a snag or something and you reach up to get more leverage and you pull on it, that rod will break right at the top of your hand. That's normally where it will break, because you're eliminating the work that the rest of the rod should do and creating a situation where you're emphasizing that ovalization. Your hand is wanting to make that your rod fold over your hand. And that will cause that rod to break, and it'll break in that location. So even unencumbered, if you load that rod to the point where it'll break, typically the initial break starts with ovalization, and then it collapses and breaks that rod over. The ART fibers are hoop style fibers, and they prevent ovalization. They fight that ovalization, so they can add a lot of strength to that rod. You still don't want to lay it on the side of the boat under load. You certainly don't want to put your hand on the rod blank anywhere off of the handle, because you will still create those forces that make it want to ovalize. But the ART definitely helps combat that to a degree. That brings us to FRS, more alphabet soup. The FRS is a fortified resin system. They found that they were having some failure, but it led them to do some research, and they found microbuckling in the carbon fibers, because they don't want their rods to break, right? They care. They don't want their rods to break, so they examine it. And to be honest with you, I got the impression talking to the head guy at St. Croix, the engineer, that it's like when a rod breaks, he kind of takes it personal. It kind of bothers him, makes him mad. And so he wants to find out why. How does this happen? Anyway, they dug into it, they found out what was causing it, and they developed a system where heating that resin and making that pre-preg become one. If they did it in a certain way, introduced the heat in a certain way, held the heat for a certain amount of time, and dropped that heat in a certain way. And that's proprietary information, specifically how they do it. But the way that they apply heat to that pre-preg was reduce that micro buckling of carbon inside and reduce that weakness that was being introduced inadvertently. They added a lot of strength without changing any weight, really. They changed the way that they essentially heat treat this material, but they don't have to change anything in the way of materials. They're not adding anything. They're adding strength without adding anything. TET is the final alphabet soup for now. I'm sure they're actively coming up with new ones up there right now, finding ways to make rods better. Even though they will tell you they make the best rods on the planet, they're still trying to get better. They're still trying to make that next breakthrough, that next thing that maybe reduces their failure rate from ridiculously low to unbelievably ridiculously low. So TET is a laser-guided cutting system, computer-guided cutting system that cuts the patterns of pre-preg that they lay on the rod. That used to all be cut by hand, and it was cut accurately, but it was cut basically in straight lines. They have this beautiful polycurve mandrel. In order to make that material line up exactly with the mandrel, they're cutting on a polycurve so that the amount of material throughout that blank is consistent wall thickness from one end to the other, completely controllable wall thickness from one end to the other. Where if you cut a form like this, and then you roll it onto something that's cut in a different pattern, you end up building a little extra material in spots where you don't need it. That's extra weight that's really not adding anything. And it's still rolled on by hand. It's lined up and put on to the mandrel by hand, and then it's rolled by a machine that puts a correct amount of pressure and heat to that blank, and then they go into the baking ovens. So to go into that FRS technology. So you have a full system from beginning to end of doing it different. I'm a big fan of St. Croix. I'm not paid by St. Croix. This is not sponsored by St. Croix. It is just a way for me to communicate to you some of the things, demystify that St. Croix alphabet soup, all of those letters and numbers on the rod blank to help you understand and make an informed decision when you go into a store and pick up your next fishing rod, your next tool to help you catch fish. Thanks for joining us. It was a long one today, and I apologize. I welcome any questions. I welcome any comments. And we'll see you for a full-length video Friday, Tip Tuesday on Tuesday. Thanks for joining us.